So now that you've learned the basics of working with predicates, we're going to move on to talking about quantification. Quantifiers are intimidating, but they are incredibly important to the strength of the predicate system. This is because in English, there are many sentences in which the subject is not a proper name, like Bob or New York City. Here are some examples. Someone will be the 46th president. Everyone loves chocolate. All humans are mortal. Bob's brother is a dentist. If anyone could get the job, Kathy can. If someone can succeed, then everyone can. And no dogs or cats, right? There's no proper name that we can turn into an individual constant for any of these. So to symbolize these sentences, we need to use quantifiers and variables. So let's talk about what those quantifiers are. There are two operators for quantification and predicate logic. They work kind of like connectives. The first is the universal quantifier, which we symbolize with the upside down A. This quantifier universalizes the claim. It says that the quantified statement is true of everything in our universe of discourse. The other is the existential quantifier. This says the quantified statement is true of at least one thing that exists in the universe of discourse. The quantifiers are always attached to a specific variable, which stand in for individual constants in predicated sentences. You should never have a quantifier without a variable, and you should never have a variable outside the scope of a quantifier. When the quantifier is introduced, you'll always see it in parentheses paired with the specific variable it governs. So backwards EX is there is some X, and upside down A, Y is for every Y. Now let's work through those examples I introduced at the beginning of this lesson to see how symbolizing with quantifiers works. First, someone will be the 46th president. Here we have the expression someone. The use of someone is a really good indication that we should be using the existential quantifier, right? That there is some X that we're going to be talking about with the rest of this sentence. Anytime you see some as part of a sentence, you're usually safe to assume that it will be an existentially quantified sentence. So here's the truth functional paraphrase. There is an X such that X will be the 46th president. I have the part of the paraphrase for the existential quantifier in bold, since that quantifier scope is the rest of the sentence, which makes the quantifier the main connective. Now we need a key for symbolization. Symbolization keys involve three things. They always involve a universe of discourse. This tells us what the range of things is that quantifier can go through to pick out. Here, because we've said someone instead of something, we can safely assume the universe of discourse is restricted to people. Next, we need to have a key for any predicates and any proper names that we have in our sentence. Here we don't have any proper names, right? There's no Bob or anything like that. We just have one predicate, PX, X will be the 46th president. So the symbolization we get looks like this. There exists an X such that X will be the 46th president. Because the quantifier scope is limited to that immediate sentence it's connected to without any other truth functional connectives, we don't need to put PX in parentheses. The convention for parentheses with quantifiers is similar to the way that we use parentheses with negations that you're already familiar with from sentential logic. We only need to include parentheses when the scope of the operator covers a compound sentence, that it ranges over another connective. We'll talk about that more with some of the other examples. Here's another simple one. Everyone loves chocolate. Here we've got the phrase every, which is a good indication we need the universal quantifier. Now we need a truth functional paraphrase that changes everyone into a sentence with an individual term. The paraphrase for the universal quantifier is for every X. So here we have for every X, X loves chocolate. Now that we have the paraphrase, we need a symbolization key. Let's think for a moment about the universe of discourse. Just like the last example, the phrase everyone seems limited to people. For instance, no one would think that when someone says everyone loves chocolate, they also mean all dogs love chocolate. In fact, chocolate is really bad for dogs. So we have the universe of discourse set. Now we need to have a key for any predicates and any individual constants. Here we don't have any individual constants, and we just have one predicate, loves chocolate, which I'm going to symbolize with the capital C. So the completed symbolization is for every x loves chocolate. So you have that upside down ax in parentheses and then cx. Now let's look at some examples that involve compound sentences. All humans are mortal. The fact that the sentence says all means we will be using the universal quantifier. Now think about how we need to paraphrase the claim that all humans are mortal truth functionally. Obviously, we're going to have that universal quantifier, and inside the scope of that universal quantifier, we're going to have the material conditional that if x is a human, then x is mortal. This entails that anything that satisfies the antecedent will also satisfy the consequent. We can't have anything that is a human and not mortal, or else this sentence will be false. Any sentence you see of the form that all A's are B's should be understood this way. So any claim you make about all of something also having another property will be symbolized like this with a conditional. Now let's give a symbolization key. Here, there isn't any particular context in the sentence that limits the universe of discourse. So we can just say that the universe of discourse is things in the world. Now we need to specify the predicates. I have hx for x is a human, and mx for x is mortal. And here's the symbolization using that key. Notice the entire conditional is in parentheses. This shows that the scope of that the whole conditional is in the scope of that quantifier. If we did not use parentheses here, the scope of the universal quantifier would only apply to hx in the antecedent. This would be bad for two reasons. First, it would not capture the meaning of the original sentence. It would say that if everything is human, then something else. And secondly, the x in the consequent with the mx would be a free variable, meaning a variable not bound by any quantifier. In the predicate system we're using, free variables are not allowed. They just don't make grammatical sense to have a variable without a quantifier. So every instance of a w, x, y, or z in your symbolizations must be in the scope of a quantifier that binds that particular variable. This example looks a bit different from the ones we've done already. It looks like we have a clear subject for the sentence, Bob's brother. But Bob's brother is a description, not a proper name, so we can't use an individual constant here. Instead, we're going to need to use quantifiers and variables and build that description, brother of Bob, into the quantified sentence. So what quantifier do we use in this case? If the sentence said all of Bob's brothers are dentists, we could use the universal quantifier, and that would look like our previous example. But instead, it just refers to one individual brother of Bob, so we need the existential quantifier. Here's the truth functional paraphrase. There is some x such that x is a brother of Bob and x is a dentist. To symbolize the sentence, again, we need a symbolization key. Our universe of discourse is people. bxy, a two-place predicate for x is the brother of y. dx, the predicate for x is a dentist. And then because we do have a proper name in this sentence, we need an individual constant, which is b for Bob. Now we can use that truth functional paraphrase and the symbolization key to get this symbolization. There exists some x such that x is a brother of Bob, and X is a dentist. Again, here we have to have that entire conjunction with both occurrences of X inside parentheses to make sure that it's clear that both of those are within the scope of that quantifier and apply to the same thing. Our next example is if anyone can get the job, Kathy can. Anyone is one of the trickier terms when it comes to deciding what quantifier to use. The phrase any may jump out at you as indicating universal quantification, but we have to look at the actual context of the sentence. In the context of this sentence, we should read anyone as someone here. Think about how this sentence could be reformulated in natural English to say, if someone can get the job, it's Kathy. So here our truth functional paraphrase is, if there is some such X that X can get the job, then Kathy can get the job. Notice here our main connective is the if then. Only the antecedent involves the existential quantifier. Here's the symbolization key. The universe of discourse, again, is people. JX for the predicate, X can get the job, and the individual constant K for Kathy. So our symbolization looks like this. Remember, the convention for quantifiers is like the one for negation. We can omit parentheses when the quantifier's scope is limited to the sentence it is immediately attached to. Here, there exists some X, JX as a whole is our antecedent, and then JK is our consequent. This sentence takes roughly the same form as the last one. If someone can succeed, then everyone can. Here we've got two quantifier indication terms, someone in the antecedent and everyone in the consequent. So let's do the truth functional paraphrase. If there is some such X, such that X can succeed, then for every X, X can succeed. The main connective, again, is that material conditional, not either of the quantifiers. So with the symbolization key, again, we have people and then the predicate S for X can succeed. We come up with this symbolization. Notice here I've used X with two different quantifiers. I've used it once here and then once here. That's okay, only because the scope of the quantifiers don't overlap at all. The existential quantifier's scope is only the SX in the antecedent, and the universal quantifier only applies to the SX in the consequent. When we get to multiple quantifications in the next lesson, where you have one quantifier inside the scope of another quantifier, we'll have to be more careful. Let's look at one last example. No dogs are cats. No here indicates that we'll be using a negation as well as using a quantifier. Before we get into the ways to do that, let's set up our symbolization key. Our universe of discourse here we'll say is animals. And then we have two predicates, D for X is a dog and C for X is a cat. So how can we paraphrase no dogs or cats truth functionally? The first way is to say all dogs are not cats. And if we say all dogs are not cats, we can do that just like the all humans are mortal example and put it truth functionally like this. For every X, if X is a dog, then it is not the case that X is a cat. And we get this symbolization. The universal quantifier is the main connective, and the negation is inside on that consequent. The other way to look at the claim, no dogs are cats, would be to look at it without the negation, which would roughly mean some dogs are cats, and then symbolize that with the negation in front. So putting that version truth functionally, we'll have, it's not the case that there is such an X, that X is a dog and X is a cat. With this reading, we use a negation as the main connective, and then put the existential quantifier inside the scope of that negation. And then, of course, the conjunction is a dog and is a cat with X is inside the quote, the scope of that existential quantifier. These are logically equivalent symbolizations. Either one of them is fine, but you do have to be really careful when dealing with contradictions and negations of quantified statements. Either of the strategies I took above work fine, though I tend to go with the second formulation where I think about the statement without the negation and then put the negation on afterwards. The logic book talks about contradictory pairs in some detail on pages 292 to 294. That could be really helpful to look at as there's more of these pairs than I was able to cover in this video. So that's it for this lesson. In the next lesson, we're going to get into more complicated cases in which we have quantifiers inside the scope of other quantifiers. The readings I recommend here cover both the basic quantification we've talked about in this lesson and the more complex types of problems I'll talk about next time.